Okay, so this morning we're going to be looking at code reviews. So the structure for doing code reviews, for doing this session is going to be that I've got this talk planned, and basically it's a very short talk, which is just going to explain what I think about when I look through someone's code and review it. And then once we've finished that, we might take a short break. And then Nick Dyer, who you probably all know is one of the alumni helpers, he did a pull request for a Sudoku challenge a while back, which never got reviewed. So I thought I'd review it now live in front of everyone. And then the idea is, once we've done that, that you will all break into pairs and review each other's code. So using the guidelines that I'm going to show you now. So that's basically how it will go. So yes, code reviews. What do I think about when I'm reviewing code? And it's funny, the first thing that you would generally think that I'd be thinking about is, does it work? But really, I'm not that interested in does it work, funnily enough. We use CI, which I'll show you, which shows whether the tests run or not. And obviously, it's a good idea that it does work. But more importantly, is that you've shown that you know how to code well. And the two, obviously, knowing how to code well means that you've made it work, but you've gone beyond that and done something extra. And I would say that instead of saying, does it work, more importantly is, has it matched the specification? So when we sent out the challenge for you on Tuesday, there was a specification in the Markdown. And the idea is that there were some quite specific steps there, and we want to make sure that you can follow those steps and turn that Markdown into some form of specification, normally through writing your tests or your Cucumber or whatever, and then making sure that when you've completed the challenge, all of the things that we're asked to do have been done. And it sounds quite a simple thing to do, but it's actually very difficult to make sure that you always pass the specification. Then we will look at, has it passed CI? We started using CI a bit at the end of the course. I know we didn't really integrate it, and it's now being more and more integrated into the course as we realize how important this is. So I will show you with Nick's that there's some of his CI is passing and some of it's failing. Yeah, Emily?
Sorry, but beyond your comment the other day when you said, can you include Travis? I've never heard of this before.
Okay, yes. So, yeah, like I say, I think it's something that I'm particularly keen on. And so I've been pushing to get it introduced in the course. Obviously, I haven't really been that involved in coaching this time around. I've been using it a lot while I've been in engineering and then feeding that back. I'm happy to explain it a little bit if you want. Yes.
Sorry, is this the same question as what is CI?
Yes.
Yeah, okay. What is CI?
Okay, interesting. Okay. Okay, that's interesting. Were any of your challenges, did they have things like Travis in them or Hound?
No, I've literally never come across those apart from the comment that you put on Slack.
Okay, my bad. It's clearly come in with the juniors who we have been definitely doing CI with them, but we must have not it must have been in that transition that we didn't get around to. It doesn't matter because it's actually really simple. And I'll show you when we get on to looking at Nick's code review, how it works. But basically the idea of CI is it means continuous integration. And the idea is that it comes from a problem, which is that, let's say I write some code. I'm on a branch, it's all good. And then I push my branch up to GitHub. And before I push, I forget to run my tests. It all happens, particularly with feature tests. Generally speaking, with your unit tests, you're doing test-driven development, so you should catch that. But sometimes you finish that, and then you forget to just double-check that all of your tests pass, or that all the feature tests, whatever it may be. So you push the code up to GitHub, you merge it in, and then someone pulls it down and says, all the tests are breaking, who did this? and then there has to be a witch hunt and a git blame, and oh, it was me, sorry, you fix it. Everyone feels bad. And it got to the point where people realized, hang on, this is a human thing. We can't be expected to always run out. Well, you should be expected to always run your test, but we do forget. And the point as well is that not only do we forget, but that sometimes if it works locally, if we did it on a completely fresh new box, it might not work because there might be some stale data in your database or something. So you want your test to be able to work on a completely clean machine. So CI came along, and the way that CI works is that it links up to your GitHub. So Travis, or we use CodeShip. It doesn't matter what, you can also set up your own. People talk about Jenkins, which is you can set up your own CI. And basically when you push a branch or do a pull request, GitHub sends a little notification to the CI server and says something's changed on this branch. And what the CI server does is it creates a brand new server, a sort of a brand new, like we said, like a dyno almost, for your code. It checks it out. It installs all of your gems from scratch, installs Ruby from scratch, or JavaScript or Node or whatever, and then runs all your tests and makes sure that they pass or not. And if it succeeds, then you get a little tick on your GitHub which says code's passed. If it fails, it says a big X on it. And what's great is you can integrate it into things like Slack so that it will then send a message. In fact, we have it pass or fail. It sends a message to Slack saying, your tests are breaking, what's up? And it will say who broke the tests, and then they can go and fix it, right? So it's really great for that. But also one of the reasons that I love it as a developer is because you can do what's known as continuous deployment with it. And this goes back to that move fast and break things. And even though we don't want to break things ideally, we want to move fast and deploy regularly. So what we can do with continuous integration, and this is where that moment where it's suddenly the fact that we've been writing all these tests throughout the whole course, it all comes together because we've got all our tests and we want to deploy. All we have to do is push to master with the latest changes that we've got. Continuous integration will run, check all your tests. If they're all passing, it will then go to Heroku and say, all the tests are passing, can you deploy for us? And Heroku will automatically deploy. So it's called continuous deployment. And it means that you don't even have to think about it before deploying. I mean, obviously it's a little bit more complex than that because sometimes there's visual changes that your tests don't catch. But it's a really great way of meaning that companies like GitHub can deploy 4 or 5 times a day, and they're relatively certain that they're not introducing too many bugs into the system. And this is where I was talking about before, about how we can move beyond move fast and break things to move fast and don't break too much stuff, actually, ideally. So that's how continuous integration works. We'll go into it in a bit more detail when I actually show you Nick's code. But the other thing that you can add is it doesn't have to just be running your tests. So Travis will run your tests and give you information based on that. But we have these other CI services, for example, Hound from the guys at Thoughtbot. And what Hound does is when you push code on a particular pull request, it's really good for, it will do a lot of my work for me. It will go and check all your style guide violations and say, hey, you violated this style guide. I'm trying to think of an example. Let's say in your style guide, it says, don't use single quotes, use double quotes. Hound can say something as simple as that. It can actually highlight indentation issues as well, which is great. All kinds of things like that.
When you say style guide, you mean something that we would have written or the company would have written as opposed to kind of like Ruby conventions?
Well, they're both, yeah. So a style guide is generally based on Ruby conventions, and most style guides implement Ruby conventions. The idea with style guides is that they vary from company to company. But if you go to Thoughtbot, for example, I guess we can, hold on, let me show you. I'll show you in a bit, actually, because I was just going to ruin the presentation.
So is it that it reads the code that's already been that's already on GitHub, and then it compares it and says, okay, it's been single quotes been used up here, so then you use double quotes down here. Is that the sort of comparison, or is it?
It uses a program called Rubocop, which is a Ruby gem. I don't know if you've heard of that. Yeah, so you can set in a YAML file all of the conventions in Rubocop to say what you want it to look for, and then using that, it will check your code and make sure it passes. It's really great. So Hound is another thing you can use. There's also another one which we haven't really got integrated yet, but I think we're looking at, called Coveralls, which automatically shows how much test coverage you have. And what I love about Coveralls is it shows when you wrote your tests. So we can immediately see whether you did test-driven development or not. So that, yeah. So I might try, maybe I'll try adding that to the challenge that we've got. I still need to throw these things on, actually. So anyway, we'll come back to that, but that's going to be another thing that we look at, just to make sure that we've got all the ticks there. And if not, you know, that's particularly if you're working with a company that often there'll be that you won't be considered your pull request finished until all of those ticks are green and it's ready for review. So what do we look for anyway? So yeah, I was wondering if you had any ideas what we might be looking for. And I'll give you a clue. They're all acronyms that I've put, and most of them are 3 letters.
Right.
Dry, yeah, that's one. Any others? Probably should have.
OOD.
Yeah, and its cousin.
OOP.
Yeah. This is good. We're getting almost all of them. In fact, you've got all of the 3-letter ones. There's some other ones. Oh, yeah, solid. Yeah. REST. That's a good one. I'd like to add some of these. Yeah. Yeah. REST. Solid. True. What one's that? True. Oh right. Yeah. Well, I guess it's true. True that. And there was some other long ones. Well, I'll show you the list. Human readable, yeah. Readable code. I'm going to write some of these down. Hold on. These are good. I did that. Solid, true. What were the other ones? REST, readable. There is an acronym for that, something about human readable. So anyway, so you see we've got OOD. That was really good, by the way. Glad to hear that everyone got those. OOD, OOP, TDD, MVC. We might not have said MVC, but yeah, MVC. DRY, KISS, you know that one? Yeah. And then the other two, YAGNI, that's a catchy one. YAGNI. So, huh? Exactly. So, particularly in reference to commented out code. You ain't. And if you ain't going to need it, don't comment it out, delete it for God's sake. No, I love that one.
Oh, Yagni, that's what I'm going to put down.
That's a really important one that only do, when we say matching the specification, what we mean is only match the specification. Don't go beyond it unless we say, oh yeah, you know, if you want to show off, you can do these things. And if you do go beyond it, you have to justify why.
You could say necessary, though, couldn't you? And therefore skip out 4 words and a silly acronym.
Yeah, I did that. I think you need all 5 words because it's something that people always forget. It kind of blew my mind when I first came across the acronym. I'd always followed the, well, you might need it, so I'll just shove in some extra functionality, right? It happens a lot. Whereas what you want is KISS. So these two go very well together. And the last one is another favorite of mine. Anyone know that one? So that is the principle of least astonishment. And I'll go into, I've got slides for all of these things, so we can go into them in a little bit more. But I love that one because it's about doing things that you would consider that aren't astonishing. And I'll talk about that in a bit. So let's just briefly go over the categories. And this slide deck will be helpful if you're not sure how to review someone's code. At the very least, you can just go through the slides and ask all these questions to yourself and your partner, you know. So you need to ask, in terms of OOD, And really, in some ways, this is just D, right? As we were talking about on Tuesday, this is about your design. Is it well designed? And you can kind of tell, because this goes all the way forward to those acronyms we're going to talk about at the end. But if you look at their code and go, huh? What's going on here? It's badly designed. Whereas if you look at the code and you go, I know what's going on here. This is really cool. Then it's well designed. And it just looks right. You get a feel for that. That is a hard thing. You get a feel for it. But you know, sometimes you look at someone's code and you think, wow, that's really neat. And all the methods are short and everything makes sense. That's well-designed code. But we can be a bit more specific as well about that, right? That the domain model makes sense. That each object exists to do one thing and one thing well. And there isn't an object which is thingy interface. You know, it's if we've got a blog site, you have your users, you have your blogs, you have your comments, and that's it. So then we've got OOP, which obviously you all know stands for object-oriented programming. So I did put solid in here, yes, of course. Are your objects solid? And generally, everyone gets a bit muddled up with some of the solid principles. The one you really want to ask every class is, does it follow the single responsibility principle? And I know I'm repeating myself a bit from this thing back here. Does it do each object do one thing and one thing well? But that's because this is so important. Does it make sense that everything in that, every method in that object follows this principle? So if the user is adding comments, is that what the user does? Should the user really be doing that? These are the sorts of questions that you'd be asking yourself. You know, if a user is trying to add things and present dates, should the user really be knowing about how to add dates together? Probably not. That's another class, that kind of thing. Also, is it well encapsulated? So, you know about this, is about getting all of your private things on the inside, not on the outside. And we've talked about that a lot in code reviews. And that also applies with the law of Demeter, that if you see an object, you know, you've got a model and it's doing something like user.comments.something.blah, blah, blah, and it's all on the outside. Is there a way that you can take all of that logic and encapsulate that inside of your object? Okay. Making sense so far? Cool, cool. Test-driven development, we're all familiar with this. So this don't really need to go over that much. How well tested is it? Do the tests read well as documentation though? This is a really important one. Particularly RSpec and Jasmine both have this feature where you get this documentation style feature. Run their tests with format documentation turned on and then read it. And if the tests are well written, it will read like a story. And it will read pretty much like the specification being talked back to you. If it doesn't, then you know that there's a problem. And then how comprehensively tested is it? So have they done unit tests? Have they done acceptance tests? Maybe they've done one and not the other. Ideally, you should be doing both. Well, you should definitely be doing both, minimum. Are there magic numbers? That comes up quite a lot. What would happen if I change some of these random numbers that are popping up? Would your test break? Is it quite, if you're just plopping numbers into your tests, it makes them quite brittle and a bit astonishing because someone looks at your code, they go, huh? Where are these numbers coming from? And the simple answer to that is to instead have numbers coming from constants or variables, right? So if we can find an example, we can go into that. Don't repeat yourself. It's pretty obvious, right? You better, but the idea of don't repeat yourself is about this idea of abstraction. Yes, so if you're seeing that there's a bit of code that's repeating yourself in 3 different places, consider abstracting that into a method. And a lot of what good programming is about is getting the right level of abstraction so that you're not repeating yourself, but at the same time, you're not over abstracting. And I'm afraid that's a point where it's hard. It's a balance and an art. But generally speaking, at this stage, you should be aiming probably for more abstraction. You know, you don't want to just write your code and then be done. You want to write your code and then look at whether there's repetition and then refactor.
That abstraction, I sometimes like you say, finding confusing because sometimes it becomes less readable because you're, say for example, like we did our project with Jake, like refactored our code and put our some of our socket stuff outside of the well, not nice, it was outside of the server, but then extracted like the individual what each of them were doing individually out, which you can, I'm pretty sure it's dry. But for me, it sometimes makes it less readable because you can't see what's going on within sockets. I don't know what's the.
It's an interesting debate, and there's no wrong or right answer when it comes to this. Like I say, this is where programming becomes an art rather than a science. I tend to think, though, that often, again, it's something that I notice when a lot of you all start, you get into Sublime and you start using Sublime, and every time you open a file, you go over to the little menu on the left and click and then open it. And again, I haven't really engaged so much with your cohort, but whenever I'm going around, I always say, Command P, use Command P. I said, if you're not using Command P, just use a text editor. Don't bother with Sublime. That's why I switched to Sublime when I did. And everyone knows Command P, right, is the file opener thing. So the fuzzy match. The reason it's so important is because generally speaking, if we're going to be doing OOP and we're doing it in that style, we're doing lots of small classes. So it is just how I work, is that I'm constantly jumping from object to object. You kind of get used to it after a while, and you use you use your text editor's features like Command P to just be jumping from object to object. And yeah, it can sometimes, though, it can be over abstracted if there's too many objects. So at that point, you can take a step back and say, maybe we've gone too far here.
Yeah, I guess that's why method names is so important, because if you've got the correct method names, the script ones shouldn't matter.
Yes, yes. And there's other solutions. People have IDE solutions, but generally speaking, I find it easier than if I open up, say, a JavaScript file that sometimes you see, and they're 1,000 lines long. And you're like, okay, well, it's all in one page and it's all there, so it's not hidden away in different objects. But oh my God, going through 1,000 lines, I'd far rather go through 100 objects of 50 lines than all of those objects crammed into one page. But it's still something that I will be constantly thinking about as I program. It's just something that's difficult. But it's good. If you're thinking about it, then you're doing the right thing. Don't worry if you're not sure about it. That's going to be the case. And again, it's a point of code reviews that you can bounce these ideas back with people. Okay, MVC, Model View Controller. Again, this is something that I come back to over and over and over. Particularly number one, have you kept your controllers skinny? If you want to keep me happy in an MVC code review, and you've got skinny controllers and the rest of the code sucks, I'm still going to be reasonably happy, because this is my number one bugbear. Although that's not true. Obviously, you want good code regardless. But having logic in your controllers defeats the whole point of MVC, which is that a controller, I always consider it's like a dumb waiter that takes your model data and passes it to the view. And it handles requests and responses, and that's it. Takes a request, gets the data from your model, passes it to the view, then spits out the response back to the server, and that's it. Similarly, in your views, keep your logic to a minimum. Either the logic should be happening in the models or in a helper, or even a view model if you really want to go further with this whole pattern. And then with your models, any logic that isn't in the controller that relates to you getting data out of your database, put it in your models and unit test them, right? Models are objects, so they should be unit tested like anything else. It can be hard, particularly with something like Rails, to do a proper isolated unit test like we use. So you do what's more of a unit test that actually hits the database, which can still be considered a unit test, but you use something like FactoryGirl or something and to put data in your database and then check that it comes out correctly. And we've talked about encapsulating logic. Oh, duplicate slide. And then finally, is your code well written? I mean, obviously this is going to be all of the previous steps apply to this, but here we have, like I say, these 3 acronyms: keeping it simple, you ain't gonna need it, principle of least astonishment. I think a lot of these all combine together. So keeping code simple is, has anyone heard of the idea of Occam's razor? Yeah. Do you want to explain Occam's razor?
Yes, the correct solution to the problem is the less straightforward one.
Yes.
So it's often used against like creation time.
Well, yes. So without getting into religion and politics, the 2 things you're not supposed to discuss. But yeah. So it's the simplest solution generally is, or the most straightforward solution is generally the best solution to a problem. And this applies all the time in coding. Sometimes, I'll give you an example. The moment when we got application forms, Paul Nikesh has to take every single one. It goes into our customer CRM system, and he then has to manually type it into another system. And he spends half his time doing it. And we're going to be fixing it this afternoon. But when we were looking at solutions, we were thinking, we could be doing this and creating this object and doing some sort of API-based system. And then we found that there's this service called Zapier. We can just basically send the data to it, and it will handle putting it into Pipedrive for us. It's the simplest solution. It's the best one. And it can be the same in code. Again, getting your code down to 1-line methods is often the best way around, rather than something which is 15 lines. And there's definitely times when you get caught in a bit of a rabbit hole and you end up with this really complex solution. And it's good to take a step back and think, was there a simpler way of doing this? You ain't gonna need it as well. It can sometimes involve that are you really needing this complex solution? But also, yes, you're not gonna need comments in your code, take them out. Not helpful comments. The occasional helpful comment is great. I mean, commenting out chunks of your code. Delete it. It's in GitHub. It's in Git, sorry. You can get it back if you need it. I'll help you get it back if you really need it. But please delete it. And then this principle of least astonishment. Like I say, I really like this one. When I'm coding, it's about looking back over your code. And this particularly gets to when you start abstracting things and trying to be a bit clever. You look back and go, am I being too clever here? If someone else comes along and reads this, is it astonishing? Is it that moment where you go, huh? Anyway, and I'm trying to think of a good example of that.
I went to the Ruby Hack Night last month, and I was like, I penned this amazing guy. He was writing Rackware, and it was all really crazy and complicated. He wanted to do something, and he was meta programming. He was writing like method missing things, and he was writing this, and it was all getting his idiot. At one point, he just went, "Oh Christ!" And I went, "This might be really stupid, but I'm not sure why he didn't just use an if-else statement there." And he realised that he could get rid of all the meta programming that he'd written and just have an if-else.
That is brilliant. Thank you so much. I was trying to think of that is the perfect. That sums up all 3 of these things, right? Keep it simple, just with an if-else statement. You aren't going to need all that other crap, and do something which is the principle of least astonishment. So it's a really great example, and those coders are really interesting because they intimidated the hell out of me when I first came into programming. Those guys that have been programming since they were born, pretty much, they sort of born with a keyboard in their hand, and so a lot of them are doing great stuff, but oftentimes you find that they don't make very good web developers or Ruby developers, because what we're looking for is these well-tested, simple solutions. And they always seem to like to go, they know they're so clever that they go for the really complex solutions that often are unreadable to anyone else. And they're so focused on the problem that they're not really focused on the solution in some ways.
But I think in some ways that's when actually we can be useful as beginners, because our first thought isn't to go through these really, really complicated ways of doing things. Our first thoughts are, well, these are the simple things we know. And if those things don't work, then we think about the more complex stuff. But I guess when you've been really senior, you've been doing it for ages, and you know all of these incredibly you know, high level stuff.
Mm-hmm. Yeah.
I think sometimes it's where actually we can add value.
Definitely, and Spike's doing a talk about being a junior later, so I'll mention that we had this chat and get him to talk about some of that. And obviously, we've been working together for 3 months, and it's been really good because he will ask really good questions as a junior in exactly that way, which will make me reconsider my own code. And the two of us together, it's worked really well, producing some pretty good code. Also, there's a concept in Zen, some of you are probably aware of, called beginner's mind. And it's this idea of an ideal in some ways, that when a beginner first comes to something like Zen, they've quite a clear mind. They don't have all these concepts, all this baggage. Oh, this teacher said this person said that. They're just simple and open-minded. And often that's seen as something to go back to. With all of the knowledge and experience, if you can get back to that beginner's mind at the same time, that's where real mastery comes in. So definitely take advantage of that, you know, and ask the stupid questions. There really, really, really isn't a stupid question, really. So, yeah. Any other on that note? Any more questions? Cool. All right. Cool. Thanks for that, Emily. Anyway, so let's take a break now, and then we'll review Nick's code.